All right, let's start week 6, finish week 5. We're on February 9th, the beginning of week 6. But you just got done doing some in-class assignments. You just got done doing some homework. So let's talk about Tuesday's in-class assignment. Well, now that I know it exists, I'll try to take it easy. That's all I can say. Thanks. Appreciate it. I can't turn the other way. I mean. All right, that's it. Week 5's done. We just edited all that, going over the homework out of the video. We're on week 6 now. Look at the kind of things we're going to talk about. Assigning probabilities, multi-step counting. Really, there's week 6 instructions, but what I want to point out is, here are the subjects today. As far as these counting rules, there's multi-step counting, combinations and permutations, but for me to talk about this assigning probabilities, I want to use the example from the multi-step counting rule. So I'm going to talk about the multi-step counting rule, then talk about assigning probabilities, then get into these other counting rules called combinations and permutations. They're also counting rules. And then we have a couple of Excel things to learn today. We're going to learn sort and frequency. I'm imagining a lot of you already know how to do sorting data, but I bet none of you have ever used frequency before. Which, by the way, this would replace using COUNTIF when you learn this. To count how many are in a set of data and put it in the classes. That's what frequency does. And then this formula, this beautiful formula, right here. The mean to the power of x times e to the power of the mean negative. The exponent's the mean negative to the e's to the power of, divided by x factorial. This is going to be a big part of Tuesday's lecture next week to prepare you for this homework. Right there, that's a major part. And that's how we'll end today's lecture if we have enough time. So you have a written assignment this week, you have an Excel assignment, they'll be posted right after class. Due on Thursday, just like always, a week from today. PowerPoints, we're talking about chapter 4 and 5, there's the key slides. I have some highlighted pages from the book that I think would help the most from this week's lectures. And then a couple of Excel spreadsheets are posted, and like usual, the recordings will be posted. I get them up, so far it's been the night after the lecture. I haven't had to go to the next day yet on any of those recordings. Been able to get them up the same night afterwards. All right, let's look at the homework, see what you got. Whoop. Come on. Here's the written assignment. We have 1, 2, 3, 4 problems, but 4 has 2 parts to it. All right. 1, I'm literally telling you what to do with number 1. Using the Poisson equation from chapter 5's PowerPoint, I'm telling you exactly what equation to use to solve number 1. Number 2, show detailed work calculating the probability on the same highway of the above question, but this is being asked slightly different. Using the same information from number 1 to do number 2, but asking you to find a slightly different type of probability. Number 3, this is also asking you to solve using the Poisson equation from chapter 5's PowerPoint. Every time I say that, it's this equation right here that I'm talking about. So number 1, 2, and 3 is all about this equation. And then number 4, it's all about using these counting rules right here. Number 4 is about using these counting rules, which we're going to learn. I'll come back when we learn these 2 rules. I'll come back and read number 4 out loud, and you'll go, oh, now I get it. Let's look at Excel. This week on Excel, we have 1A, B, C, D, and E. So we have 5 problems on Excel. Put all your equations in these 5 yellow boxes to the right. Every question is based on the information at the top there in the big print. A textile manufacture process finds out on average 3 flaws occur every 60 yards of material. And then you have 5 questions based on that given information right there. And you're going to write Excel equations, solve those. Again, that's all, this part is all on Tuesday. So let's start with this multi-step counting rule. Right here, this multi-step counting rule. Are you ready? This is it. I need you to imagine, because this is real. This is how it's done in my experience when I was in management. I was usually in charge of the finances and money and business side of everything. And so we would have meetings, and sometimes I would have millions of dollars I'd have to invest. But where I worked when I usually did this, our rule was we had to take almost no risk on our investments. That if we had all this extra cash, that we always had to invest it in things that were insured type investments, such as certificate of deposits. When you're working with large amounts of money, banks and credit unions all around the United States, and I had to invest money all around the United States to keep it protected. Because when you invest in federally insured accounts, you're only protected up to $250,000. So if you have $1 million to invest, you're working for a company, you can only put $250,000 or really a little less, because you want to have the interest you're earning insured also. So you can only put up to $250,000 in each financial institution. So I'd have to find 4 financial institutions. And as you're predicting the use of that money, you want to make sure that money's not in a CD wrapped up for a long period of time. So most of the time I was investing in short-term certificate of deposits, called 30-day jumbo CDs. Now here's what I learned when I first got into managing a ton of money, is that all the rates are negotiable, and that just totally blew my mind. I thought what you're reading on websites, what you're calling and getting rates on, hey, what's your 30-day jumbo CD for over $100,000 or over $200,000, and you get the rate. Then you make another call, and you're spending like 3 hours trying to get the best rate you can, and then you electronically transfer the money, and then they invest it, it's invested. But you don't want to invest it for too long, and that's how it's done. Hang on, I was going to make a point here. The point I want to make is, when determining how to invest money, if you're going to take risk, most companies will get all the top management involved, the key players involved, the president of the company, the head of financial, the head of whoever's driving the revenue, and so on. In this case, this would be an example where a company's saying, hey, we have all this extra money right now. I want to do a 3-month plan, short investment, and I'm looking at actually investing in 2 companies. Now, this would not be insured. This is not something the companies I worked for would ever do, but there are a lot of companies that do this. So this is why I want to make sure you can feel the picture here. You're in top management. You're at the meeting. And I'm the one bringing this to the meeting that you're at with me. And I'm bringing this to your attention. I'm saying, hey, for the next 3 months, this extra money we have, like thousands of dollars, if we go with Markley Oil for 3 months with this much money, here's the 4 options that could happen. If Markley Oil has this happen the next 3 months, we could make, this is in thousands, $10,000 on the investment. If Markley Oil has this happen the next 3 months, we'll gain $5,000. If this happens though, or the economy does this, we'll break even. And worst scenario is, if the economy does this and Markley Oil does this, at the end of the 3 months, we'll lose $20,000. There's the 4 possible outcomes. Everybody with me so far? All right, you're at this meeting. I just presented the 4 outcomes to you. I haven't said anything about, the background of the company, maybe a little bit. We talked about the company, about the investments, but here's what the 4 outcomes could. Now, the other part of the money, we're looking at Collins Mining. And Collins Mining said, okay, here's what we need the money for. Here's the 2 possible outcomes that could happen based on economic circumstances and the results from what we're using this money for. Either we're going to pay you back $8,000 in the investment, or you're going to lose $2,000. You get all your principal back but the $2,000. So there it is. Now, the counting rule for multi-step, this is multi-step because we have more than one decision to be made here. The counting rule says, take however many outcomes there are with one, multiply it times however many outcomes there are in the other one. That's the total number of outcomes from this particular decision of these 2 investments. So, let me go to the next slide here. How many outcomes? There's 4 on one, 2 on the other. How many outcomes altogether for these 2 combined? No, you don't add them. You multiply them. 4 times 2 is 8 possible outcomes. Here they are. These are the 8 possible outcomes. The Markley Oil, we could either make, there's 4 different ones, but there's 2 of these. So we could make $10,000 on Markley at the same time at the end of 3 months, make $8,000 on Collins. We'll be $18,000 ahead if those 2 things happen. But yes, we could make 10,000 on Markley, but Collins Mining, there's the possibility of losing 2,000. So we would be at 8,000 up. Go down here. Markley Oil, we could lose 20,000. At the same time, we could make 8,000 on Collins Mining. That would put us down though 12,000. But the worst possibility is Markley Oil, we could lose 20,000 at the end of 3 months, and at the same time, lose 2,000 on the Collins Mining, be down 22,000. That's the worst possible outcome. What's the best outcome, total outcome, at the end of 3 months? How much could we make? 18's the best. 22's the worst. Okay, now let's look at this. Out of these 8, how many of them could we lose money in the big picture? Say it again, Steve. 3. 3 of them. Look at the totals over here. There's only 3 of them with negatives. That, however this turns out, these 3 down here at the bottom, even if we have a break even here and a gain here and a gain here, oh, that's a loss. Gain here and a break even here, these last 3 still turn out to be overall loss of money. Okay. Everybody see them all, right? Now, you're about to learn what's called the classical assigning of probabilities. Right now, we don't know the percent chance of gaining this 18,000. We don't know the percent chance of losing that 22,000. Hypothetically, if I said to you, let's apply probabilities to these possible outcomes, just like rolling a dice, to call the classical method. When you roll a die, one die, what's your probability of rolling a 6? 1 6. You guys got it right away. You're saying, because you've learned, it's the same probability on every side of the 6-sided die, correct? That's called the classical method. And when it comes to anything, however many outcomes there are, if I said assign probabilities based on the classical method, you do the same thing you're doing right now in your head with the die. How many outcomes do you see here with this particular experiment here of these 2 investments? How many possible outcomes are there altogether? 8 of them. So what would be the probability of us making 18,000 if I said we're applying the classical method? 1/8. Which happens to be 0.125, I think. Someone can check on that. It would be 1/8 all the way down. 1/8, 1/8, 1/8, 1/8. And so now we're looking at this decision, but in real life, the classical method would not be used in this. Matter of fact, I've been at meetings when we talked about investments, and it's just like the method that's used when it comes to investments is we got to look at the historical evidence of how that investment has done in the past, and look at what affects that investment, the economic possibilities that could affect that investment. We look at the financial statements of these 2 companies for the last 4 years at least to look at what's heading. We got to make sure they're cash flow positive. We got to make sure they're heading in the right direction. Is net income going up? Is revenue going up at some kind of a steady pace? You know, does it make sense with how the whole economy is growing? Are they at least growing at that pace or better? That type of thing. All of these things taken into consideration. So we would never use the classical method to assign the probabilities, but you get it. If I would have had 12 outcomes here, how would you assign the classical probability of that first outcome? 1/12. It's 1 divided by however many outcomes. That's the classical method. You got it. In real life though, looking at these 2 companies and possibly investing all this money and having these outcomes, we would use what's called the subjective method. Let me highlight that. This is it. And it is as it describes. It is subjective. It is humans' opinions. And that's the kind of debate that takes place in a good meeting when it comes to investments. Is, okay, what kind of risk would we be taking with the Markley Oil? What kind of risk are we going to be taking with the Collins Mining? We know for sure one of these 2 outcomes on the Collins Mining is going to happen. But is there a better percent chance of making 8 or a better percent chance of -2? Or is it truly a 50-50 chance on this investment? What have they done historically? And so those who look at all this information can then come up with a subjective percent chance. And that's what's debated. Okay, well, let me ask you this, so let me change these probabilities now. Whatever method we use, we know that one of the outcomes have to happen. And because of that, that means whatever percentages you put on every outcome, whether it's 12.5%, 12.5%, 12.5%, they have to add up to 100%. The percentages that get put on each possible outcome, the probabilities, have to add up to 100%, because in these situations that we're talking about, one of these outcomes are going to happen. One has to happen. And so the debate goes on, and someone says, well, there's a really good chance that we'll just make 5,000 on this company and 8,000 on this one. And so they said, this one needs to be the biggest percent because all the data says that one will be the most likely outcome for both companies. So those two together would be the most likely outcome. That's the kind of thing we'll be talking about. Well, what's the chances of this truly losing 20,000? Really small from everything we're being told, or everything that we can see is really small, and losing that at the same time, also pretty small, so maybe this one will be the lowest, or that's the kind of debate that goes on. But let me show you, let me see here, hang on a minute. Here are all 8 outcomes, just like I have right here. All right, we gotta skip these rules. Here's the methods, the classical method, the subjective method, and the only other one we haven't talked about yet is relative frequency method, because we've already talked about it so much. I didn't bring it up right now, but we will. And then, here's the classical method. We're rolling a die. What could be the outcome? 1 or a 2 or a 3 or 4 or 5 or 6. If you use the classical method, you would put 1 over n, however many outcomes there are. 1/6, 1/8, 1/12, just however many outcomes are possible underneath the 1 is the classical method. Now, skipping relative frequency to go to the subjective method. Here's the subjective method, hypothetically, after we just got done with our meeting and we all debated the 8 outcomes. And look, after we got done with the meeting, we ended up deciding that gaining 5,000 on the first investment, Markley Oil, losing 2,000 on the Collins Mining is going to be the highest percent chance. It's at what, 26%, right? 26% chance. Okay, now stare at this a minute. You ready? What's the probability that we'll lose money at the end of these 3 months? Just tell me what numbers you're using to answer that question. Let me say it again. What? Say it again, I heard it. There you go, everybody hear that? I said, what's the probability that we're gonna lose money at the end of these 3 months? There were only 3 of the outcomes that show us losing money. Those are the 3, now that we have a probabilities assigned, those are the 3 probabilities we would add together to answer that question. So there is a 12 plus 2 makes 14 plus 6, 20% chance we could lose money. Now in the real world, at the end of a meeting, if we all decided on these probabilities, and then we go, okay, do we go forward? When there's a 20% chance of losing money in the real world, we would not make this investment. Any meeting I've ever been at, the percent of losing money has always been 10% or less to go forward with an investment, if you're gonna take risk. So right there, we've already been able to come to this conclusion that we probably won't even do this investment. Go ahead. Again, it's subjective. It's all through, hey, I've studied these companies, or at the, let's say, when I'm in upper management, it's called the executive team, we would meet every month religiously, but we would, between months, you would start discussing this with other executive committee members to say, hey, will you do a little research on Markley Oil, and I want someone to be ready for the next meeting so we can debate whether we think that we want to invest in these companies and have these possible outcomes and the risk we're going to take. Subjective, meaning it's just from everybody talking about it and saying, I think there's a 50% chance of this. Here, let me give you a good example. I forgot, I put this on the board. You ready? Here's a timely example. I put it on the board and forgot all about it. Here we go. Hang on. There we go. You ready? Okay. Is this a 50-50 right now? Should I go with the classical method? Is this 50-50 chance of each of these teams winning the Super Bowl? When is the Super Bowl? In like 4 days? Is that right? Or 3 days? Is it in 3 days? Friday, Saturday, Sunday. 3 days of Super Bowl. Is it 50-50? Yes or no? Yes, it's 50-50, what I heard back here. No, it's not 50-50. Matter of fact, I went online to see if all the bettings are saying this is an even match, and one of these teams, from what I saw, I'm using Caesars, what's it called, online betting, bet book or something? Yeah. Sports book or whatever, I'm using Caesars. They have one of these teams favored over the other team by 1.5 points, which tells me that they're saying, we'll take your bets, but we're not giving a 50% chance for each team. They're saying one team has a better percent chance than the other, right? That they're not exactly even, supposedly. Which team do you think is, according to what I saw on the internet, is being predicted to have a better chance of winning the Super Bowl than the other?
Kansas City.
I wish it were Kansas City, but it's not. They're saying Philadelphia's favored. Is anyone else saw this on the internet? Or is it just me? Huh? Yes, it's saying by 1.5 points that this. So I don't know the calculation on how they got what they got with 1.5 points, but they're kind of saying like this is more like. No, 1.5 points would be closer than that. That's a bad example. 1.5 points. They're saying this is like maybe. Hang on. I'm going to go with 53% to 47% chance of winning.
But they didn't even put it as 58. Actually, they put it as 58%. I saw it today morning.
Who says 58%?
I saw it 58%.
58% chance. So that'd be a bigger spread than 1.5 points probably. But here's the point I'm trying to say is, not every betting sports out there is going to have the exact same percentages. They're not going to. Matter of fact, there may even be like Ali's saying, there may be a sports book out there that's saying Kansas City's favored possibly. It's subjective, which is exactly what happens in business sometimes. We cannot firmly predict the future. We know that one of these 4 things are going to happen with the Mark Leola. We know one of those 2 things are going to happen with the Collins Mining, but we can't predict it. We don't have the information or the ability to see the future. So the only way to put probability to those is to use subjectively all the information we can get our hands on and then use our best judgment. That's subjective. That's the subjective method. Just like the Super Bowl. The subjective method is being used to determine who's favored. And I tell you, sports companies who take bets put a lot of research and time to come up with these percentages, to come up with that spread, because they're talking about millions of dollars being bet that they have to then pay off if they're wrong, if they miscalculated this. They're trying to make it as an even bet as possible, so that half the money is paying off the other half the money, and they're keeping their little portion. So that's how important for them to be subjective about that spread between the 2 teams. And that's what's happening when you're talking about millions of dollars. That's the kind of, it's a heated debate in the meeting sometimes to figure out what percent. But you've got to get percents on these decisions so you can make the best decision. Right now, I'd start calculating the expected result. I take 20% times 18,000, 8% times 8,000, 16% times 13,000, and add all those results together. That's called your expected value. And if that should be positive. If that expected value, if I took all those and multiply them, if that expected value comes anywhere close to 0 or less, that is for sure telling us never do this investment. Walk away from it now, just end the meeting. That's how important putting these probabilities to these decisions are. More and more companies, the bigger they get, every decision is involving probabilities in the decision to make sure they're putting the odds in their favor. That's how you make decisions. Which decision will put the odds in our favor? That's how you make good decisions. Not every decision is going to turn out to be good, but you'll come out way ahead by making sure the odds are in your favor on each decision. Because in more cases than not, that decision is the one that will turn out because the odds were in that favor, a higher probability. Okay, so we learned now how many outcomes there would be in a multi-step counting situation. We learned the classical method and the subjective method. Let's review the relative frequency method, even though I know you all remember it. In this example from chapter 5 power, is this chapter 5? Chapter 4 PowerPoint, excuse me, chapter 4 PowerPoint. In this example, this tool rental company says, hey, we want to try to predict the future of tool rentals based on the past. That's where relative frequency comes in. It uses the past information to then come up with percentage chances of that being repeated in the future. So how many days did they go back here? They wanted the probabilities that went back of how many of these car polishers they rented on each day, going back 40 days. So they looked at the last 40 days and they said, okay, the most we've ever rented in the last 40 days are 4. The least we have ever rented per day is 0. And then they counted how many for each result. Either they rented 0, 1, 2, 3, or 4. And there's the results. Now to turn those into probabilities, what percent chance is there we're going to rent 2 tomorrow? What percent chance is there we're going to rent 4 tomorrow? We got to take each of those numbers and divide them by the total number of days, 40, because they add up to 40. 4 divided by 40, okay, there's 10%. 6 divided by 40, there they are. 4 divided by 40, 10%. 6 divided by 40, 15%. 18 divided by 40, 45%. So if I said, oh man, hey, I don't know, should I get this polisher fixed or shouldn't I get it fixed? What's the probability I'm going to lose a rental tomorrow because I have to get it fixed? I guess it still works, but I want to get it sharpened or something like that. What's the chance of me not being able to rent tomorrow? Whatever the decision is, you now have probability based on historical information where you can say, oh, let's see, 45% plus 25% plus 5%, there is 40, 50, 60, 75% chance I'm going to rent 2 or more tomorrow based on the past. That's a pretty high percent chance. So I want to make sure and have at least 2 or more to grab that possibility. I guess I don't need 4. There's only a 5% chance I'm going to need 4 tomorrow. So maybe I could take one of them and have it cleaned up and take that chance. Anyway, that's called relative. You guys seen this 3 times now, so I know you know it. All right, let's get to the other part, combinations and permutations. Okay. This is the counting rule for combinations. We're on slide 8 from chapter 4 PowerPoint. And I want to just mention the letters and what they represent. The uppercase N, that's in the numerator, factorial, represents the total number of possible data, total number of pieces of outcomes actually, or that you could choose from. The small n is how many you're choosing. Usually the small n is a smaller number than the big N, but they could be the same number. They could be the same number, but in most cases, the big N is the bigger number, the small n is the smaller number.
What do you
In the
mean?
denominator, go ahead.
Oh, sorry. What do you mean by smaller number? With the smaller
Like if the big N's a 10, the little n might be an 8 or a 7 or a 6, something smaller than 10.
Okay.
So the story's gonna have 2 numbers in it. You're trying to determine which one's the big N, which one's the small N. Because that's it, there's just 2 numbers here. The big N factorial, if that's let's say the big N's a 5. 5 times 4 times 3 times 2 times 1. There's the numerator. And the denominator is the small n factorial, the big N minus the small n in parentheses, it then factorial, then multiply those 2 results, the 2 factorials. Let me say that again. Do the parentheses first, subtract them. Then factorial, do the small n factorial, then multiply those 2 results. That's your denominator. That's what gets divided into the numerator. All right? Are you ready for an example of that one? Then we'll talk about permutation. Usually I jump right into permutation, but I can tell we need to see an example, I think. We're going to have to go to page 149 from your book. Hang on. Right there. Let's see if I can zoom in on this. The bottom of page 149. Here's a perfect example of a combination. The Little League coach, oh, no. Wait a minute. Hang on. I want to make sure, because it shouldn't say from above. Anyway, let's say this Little League coach from above has 3 more players, so the team now has backup players. So his team has 12. And, shoot, it doesn't say it. I guess you got to look at A. 9 positions. All right, here we go. Whoops. Right here it says the Little League coach has players on his team. He has to assign them to the 9 positions on the field: pitcher, catcher, first base. And we're asking about how many different ways to do it. But here we are. Now we're going to A. This Little League coach has 12 players to choose from. Has to put 9 out on the field. And the order of selection does not matter. Just, we gotta select 9 out of 12 and put them out on the field. How many different ways could 9 players be selected out of 12? 3 players are gonna have to sit out to start with. There's how many different ways could 3 different players be sitting out? So that's where the counting rule comes in. So now, what are the 2 numbers on that story? 12 and 9. There's 12 players to select from. We're trying to pick 9 out of the 12 to place out on the field. So let's go to the formula again. Whoop, I'm sorry, hang on, I forgot. It's right here in it's being shown in the book right here on the next page. Here it is, the 12 is in the numerator, factorial. 12 times 11 times 10 times 9 times 8, which by the way I calculated, that is, at 12 factorial is 479,001,600. There's the numerator. The denominator is 12 minus 9, we're doing that parenthesis part, which equals 3, so that's 3 factorial. That's easy, that's a 6. 3 times 2 times 1 is 6. So we did the 12 minus 9 factorial times 9 factorial. 9 factorial, you ready? Is 362,880. Now, if we take that number, multiply it times 6, divide it into the 479 million, we would get 220 different ways of selecting 9 players from 12 players on the team. Everybody see how I calculated that? For 220 of them. All right, now let's talk about permutations. Everybody see I just used the 2 numbers and plug them in. Permutation now. Look at the permutation calculation. Almost, remember, let me go back and forth. Tell me, what do you see, the numerator or the denominator, that makes this permutation equation different from that counting equation? Numerator or denominator? Denominator. The difference is, you don't have that little n factorial in the denominator. That's out of there. Just the big N minus the small n factorial. There it is. N, uppercase n factorial over uppercase minus lowercase n, then factorial. Now here's how you recognize a permutation. It's right here. These words, I would write these down. The statement about how many you're selecting out of how many will say these words, something like, where the order of selection is important. I used to always say, where order matters. Where the order of selection is important, it has meaning, that the order in which the players are being selected matters. All right, so now, look at this permutation example, which is on page 150, down middle towards the bottom. Here we go. Now it says, let me go a little closer. It says, now suppose the Little League coach from the previous example recognizes the 9 positions of baseball are quite different from each other, and that it matters whether one player is pitching or whether the same player is in the outfield. So in this case, if this were a problem, I'd say, now this time you have 12 players, and you have to select 9 for the positions, but the order of selection matters. If you see those words, you know then to use permutation. The numbers haven't changed. How many are you selecting? How many players do you have to select from? 12. How many are you selecting? The 2 numbers are the same, but the formula is a little different because the denominator now doesn't have, ready? That. Is that right? Is that all I had to remove? That was it. Oh, I'm sorry. That. Let me put it back. Fix it on your paper. I had crossed out the wrong one. Instead, it just has the 12 minus 9 factorial, which is 3 factorial. That's all the denominator. 3 times 2 times 1, 6. that whole big number's gone. And so a permutation compared to the combination, if you're using the exact same numbers, is always much larger because that denominator is so much smaller than a combination. So if order matters, all right, you have a lot more different possibilities of selection of 9 players out of 12. Matter of fact, 79,833,600 of them. That's how many different possibilities because order matters. Can we do these? Let's look at these. Let me just read these to you real quick. You ready? Your homework. Whoop, come on. Get back out of here. Your homework says, you're the manager of a local bank branch. You have 5 tellers scheduled today, but only 3 teller stations available. You decide to randomly select 3 tellers to be assigned to the 3 stations. A, how many different ways can you select 3 tellers if order does not matter? B, how many different ways can you select 3 tellers if order matters? Did I just give it away how to solve these 2? Yeah. Oh, thank you. Okay. Kind of makes it easy now? Okay, all right. All right, so today was all about those 2 problems. And Tuesday's all about these top 3. Now, as a matter of fact, what we're gonna talk about just a little bit has to do with these top 3 problems on your written. Let me get to it. All we got left now, oh no, wait, what am I saying? I'm sorry, hang on, before we get to the fun stuff, let's get these out of the way. Sort, you ready? We're gonna sort some numbers. Let me grab these numbers right here. I'm gonna copy them. I'm gonna paste them right over here. Matter of fact, not even where they're supposed to be. There we go, paste. Boom. Okay, there they are. I want these in order, so you gotta be on your home tab, on your Excel spreadsheet. Go all the way over where it says sort and filter, and click that little arrow. And then do you want to go from smallest to largest? Do you want to go from largest to smallest? Or do you want to do a custom sort? I want to do from largest to smallest. So here we go. And there it is. 97's on top now, 993, now 91, and now it's in order from largest to small. I could have selected smallest to largest, and it would have turned out like it is over here. Can everybody sort data from smallest to largest or largest to smallest now easily? Yes. And this goes horizontal, however you have it highlighted, horizontal, vertical, however your data is, you highlight it, hit that sort, and now we'll put it in order. I can tell you in the past, we've had problems where you needed the data in order from smallest to largest to answer the question. So that's why this is kind of useful. All right, so there's sort. Let me get rid of this so the other class. Whoop. Do that, just grab a blank and boom. Come on, get back. All right, now, frequency. This is very similar to our Excel assignment. Here's our data. Let me scroll this up a little so you can see. Our data goes all the way from, let's see, it goes all the way from C9 to C24. So there's our data. Here's our classes. So we already decided our classes are what? 9 in, right? 0 plus 9, 10 plus 9, 20 plus 9. So our class sizes are 9. And here's our classes right there. 40 to 49, but here's what's different. 50 and above. Not 50 to 59, 50 and above. Now to use frequency, you have to create bins. A bin for a class is wherever the class ends, the highest number. So here's the bins. 9 is the highest number for the first class. 19, then 29, then 39, then 49, and I had to leave that one blank, which tells Excel that one's to infinity. That the bin is infinity, meaning it's some number and above. It has no limit. So then you're going to write an equation using, and follow the directions down here, but these are old directions, so you don't have to do as much. You do that first line right there, writing your frequency distribution formula. This is going to be where it goes to where the data's at, it then goes to where the bins are, it says, oh, this is the first bin, counts all of them that are in that bin, and puts the number there, and it will do it for all of the classes. This is instead of using count if. Everybody with me? Instead of using that count if on that assignment. Equals FREQ, there it is right there. I'm going to double click on the word frequency. It says, where's the data? That's your first thing. So the data happens to be, matter of fact, instead of typing it in, it would have been what? C9. So I'm going to highlight, I'm going to left click, I'm going to hold my left click down. I'm going to drag from C9, look how it's typing. C9, C15, C16, C19. I want it to be C9.C24. So I dragged it and I'm letting go of my left click now. There it is, it typed in C9.C24, put a comma, not a colon, a comma. Now it's asking for the bin array, which means where are the cell locations where the bins are. This is where the number one mistake. People will leave off that empty cell bin, which means infinity. You got to include that in this array, that empty cell that represents infinity in this array. So I'm not just highlighting F12 through F16, I got to highlight F12 all the way to F17. So I left click on F12, hold it down, I'm dragging it, and I got to go past that 49. I got to get to that blank one right there. So now let go. The bin location, F12 colon F17. Then you put your ending parenthesis. Now when I hit enter, this is going to copy this equation, but change it for every class below. And at the same time, it's going over to the data and counting how many numbers are in each class and coming back with that count for you. You ready? Equals. There it is. Look how fast that was. That first bin only has one number between 0 and 9. The second one has 3 between 10 and 19. Can you imagine only having to write that one equation and then you highlight the other 5 classes on that Excel spreadsheet and it counts it all for you like that? Would have made it a lot easier than those count if statements, wouldn't it? Well, I don't know why you didn't do this. I just don't know. But there it is. Now you know. We would not have known how to use count if that well now if we hadn't done this, right? And that count if is an important as used because you will be learning in your future simulation. And the things you're learning right now is where these are mostly used. Simulation, and that's the big deal in the business world. The big businesses are simulating different decisions before they make them, especially manufacturing. Simulation. They want to simulate, if we go forward and spend $10 million now we're going to make golf bags and sell them, are we going to make money? And they simulate the cost of goods. They simulate the cost of labor. They simulate the cost of materials, which gives you your cost of goods. They simulate the overhead. They do it so many different times, 1,000 different ways. If we sold this many, if we sold this many, if we sold this many, 1,000 times, all the different amount we could sell, all the different overhead we could have. And then they look at the bottom line. This one says we're making money. This one says we're losing money. This one says making, then making. And out of the 1,000, how many did that simulation say we're going to lose money? And if it says we're losing money, what's 10% of 1,000? 100? If it says we're losing money less than 100 times out of that 1,000, we might want to go forward with this project. That means we have over a 90% chance we're going to make money according to that simulation, and it helps make the decision much easier. Whether you should spend $10 million to start making golf bags based on all the information you're able to collect. The head of marketing is a big part of that, all you marketing majors, because they're the ones that are help guiding how many of these golf bags can we sell, how much can that revenue really be in this simulation. And then you get a range of that revenue and you say, part of the simulation is having bad revenue, part of the simulation is having great revenue according to the marketing director, and then part of that simulation is having average revenue. And you simulate every possibility. That's the big deal, and you guys have got to learn that. So it's going to be before you graduate, I'm sure, in one of those classes. I don't remember. I taught it in management science. Sometimes it's taught in operations management, the advanced operations management. So I'm sure you'll see it somewhere. Now, the only thing we have left today, how are we doing on time, is the best part of today. I love this equation. There it is. It looks so difficult, yet it's so easy, because there's really only 2 numbers you got to focus on in this equation. What is it you're being asked the probability of, and what is the mean average amount? The mean is that little mu symbol. I have it written with the word mean here. Mean to the power x. X is what you're being asked the probability of. That mu symbol is the mean. So here's the mean to the power of x, e to the power of the negative mean. The mean is what you're told in the story is the average amount. X is what you're being asked to find the probability of. And E is always 2.718281828. Blah, 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 like pi.
We have to memorize what E is?
You don't have to memorize it because it's open book, open note.
Oh yeah, that's true.
But I have used it so many times in my life that I have it partly memorized. 2.718281828, blah, 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 blah.
Can you just press E on the calculator?
And you just push E on your calculator. Absolutely. Hang on, let me just push E. There it is. 2.71828182845904522, blah, 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 blah. Just like pi. So anytime there's E in the equation, you know. And you know, and matter of fact, this rule for this class is you only have to go 4 digits to the right. So you could go 2.7183 if you wanted to. That could be your E, because the rule is 4 digits. But, you know, I used to at least use 2.71828 because it repeats, so easy to remember. So that's why I always go that many digits. But you don't have to. Go however many you want. So it's E to the power of negative mean. Let's take our E, we got it right there. Make up a mean. You ready? 8. Here we go. So I'm taking E, and now here I'm hitting X to the power of Y. When I hit this key, it says whatever number's there is your X. Whatever number you're about to enter after hitting this key is going to be the exponent. So I'm hitting X to the power of Y. I want to put it to the power of -8 because you have to put it to the power of negative mean. And she said use 8 for the mean. So I'm going to put an 8, but before I hit equals, I'm turning it into a negative. Now notice, just like Excel, it's got that little, when you're writing, you got that little top hat there, which means to the power of. So this will be E to the power of -8, then hit equals. 3 point, is that right?
3
Oh, no. Oh, it's such a, you gotta take, see that E -4? That means move the decimal 4 places to the left. So this is really, gosh, we shouldn't have used such a big number. I gotta move it 4 places left. So how many zeros would that be? 1, 2, 3, 4. So that's really 0.000335. Now we're at the point where you got to at least go 4 digits. We got all these leading zeros here. That's what we're having. We're gonna have a whole bunch more equations coming, by the way, where you have too many leading zeros. That's why we got to go at least 4 digits to the right. But by the way, on your calculator, if you ever get that E to the -4, if you get an E to a positive number, it means the answer is really the decimal that many places to the right. E negative number on the end of your answer means really the answer is moving that decimal that many places to the left. There's some leading zeros involved. So that's really our E to the positive negative. Look at the top. So, you ready? Here's the deal. I want you to recognize, you know what E is. I want you to focus on one of the 2 numbers, the mean and the X. Patients arrive in an emergency room, emergency hospital, on an average of 6 per hour on weekend evenings. What's the probability 5 arrivals will come in the next 60 minutes? What's my mean? 6. What's the question about?
5.
5. There's the 2 numbers. Ready? 6 and 5. The mean you said is 6. 6 to the power of 5 we're asking about times E 2 point, what is it again?
71828.
1828, thank you. To the power of what?
To the power of 5.
No.
6.
Negative
-5.
6. Negative mean.
Negative.
Negative mean. Divided by what?
Divided
Now say
by
it.
5.
Thank you.
Factorial.
Factorial. 5 times, 4 times, 3 times, 2 times. That's it. Most of the points are you being able to figure out which numbers are in that setup. That's most of the points for this problem in your next quiz. Right there. On that problem where you know you're going to have to manually calculate a Poisson question, is you be able to recognize which number is the mean, which number you're being asked about. All right, are you ready? Are you ready? Are you ready? It's not going to be that easy. Oh, wait. Look, I was adding a bunch of drama to that, Ali, so go ahead. What's your
I was
question?
about to say, because it's a negative exponent, don't you
Yeah.
have to bring it to the denominator?
No, leave it just like that. You're going to enter in the calculator like this. Let's do this one. 2.7, matter of fact, I'm hitting the E key. E to the power of X to the power of Y and it's 2 what? Is it 6? I'll make it 6, but then I gotta make that 6 negative, and then hit equals. So this is gonna be, this right here, this part of it is 0.002525. That is just this part right there. So leave it just like that. And then I'm gonna multiply that now times 6 to the power of 5, times that 0.0025. Show your work. Wait, back to the drama. You ready? It's not gonna be that easy. Are you crazy? I can't believe you guys are packing up. You're gonna need to write notes. You're gonna wish you didn't pack up. Are you ready? Hang on, let me get this where you can see it. I just said the mean is 6 per hour. And I just asked you what's the probability of 5 coming to this emergency room in 60 minutes? 60 minutes is an hour. So this was easy, 5, 6. But look at the next question. What's the probability of 4 people arriving in the emergency room in 30 minutes? What? Say it. That's a half an hour. So let's figure this out. Here we go. Let's see, it's asking about how many arrivals. What's my X?
6.
No.
Oh, 5.
No.
What?
4.
I thought we were
X
still
is
doing the first
always
one.
what's being asked about. You never change it. It's 4. 4 per 30 minutes. So here's my X. 4 factorial. We got, where else we have? Whatever this is to the power of 4 right there. There's our 2 4s. Right?
It would be
What's
3.
the mean?
3.
Oh,
'Cause
look at him.
6 per
Look
hour.
at him.
divided by
Everybody
2.
know what he did?
What did I
Everybody
do?
understand what he did?
It's the half hour, right?
Yeah, because the question's being asked about a half hour, you must convert the mean to match the interval being asked about in the question. Don't change that 4. Never change what's being asked about. The conversion takes place in the mean. Only the mean gets changed. Perfect though, because that question's about 30 minutes, he said there's 6 per hour is the mean. If a half hour is half of 60 minutes, the mean must also be cut in half. So that would be 3 to the power of 4 and e to the power of -3.
What if it was 20 minutes?
Yeah, 20 minutes. Go ahead.
That's
Hang
1/3
on.
of it.
Hang on. Well, 4 per 20 minutes, that's a third of 60 minutes. So what would be mean? What would be the mean instead of 6? I can't hear you.
2.
2, exactly, a third of the 6, because 20 minutes is a third of the 60. That's a big revelation right there for you guys to realize. These questions are most likely on your homework. Yes, there'll be a question that has the exact same 60 minutes and 1 hour and 60 minutes, and there no conversion has to take place. But you have also, for sure on your quiz, questions where you need to convert that mean because the interval being asked about is going to be different than what's described in the mean. Go ahead. You got to take whatever. Because this says 4 arrivals in 30 minutes, you got to convert the mean to be however many it would be in 30 minutes instead of an hour, because it's being told you about an hour. All right, hang on. What time? I know you guys are all packed up.